I'm very pleased to welcome Sheila Olmstead here for our lecture today. This is the last of a series of 3 lectures that have been sponsored by the Water Institute in March. Sheila is an associate professor of public affairs at the Lyndon B. Johnson School of Public Affairs at the University of Texas at Austin, and she joined the university there in 2013, and prior to that she was at Resources for the Future, which is a well-known think tank which all environmental economists aspire to work at in Washington, D.C. And prior to that, she was a professor of environmental economics at Yale University. She completed her PhD at the John F. Kennedy School of Government at Harvard. And Sheila has an extensive resume and has published in many prestigious journals in the area of water economics. So we're really looking forward to hearing her talk today. So welcome, Sheila.
And I have that one, so I think you can.
And I'll just say that, so I guess your talk will go for 50 minutes to an hour. So we'll just go right through, and then we'll have time at the end for questions.
Okay, thank you so much, Margaret, for that introduction, and thanks to the Water Institute for having me here today. I'm mic'd both for the live streaming and for the room, so you can hear me, but then it looks like I'm wearing 2 6-shooters, but I'm now from Texas, so I'm actually very comfortable with that. Okay, so what I'm going to talk about today, I work on research in a lot of areas of water resource management, water resource policy, and economics. But I've started recently 2 projects that are both, I think, kind of within the area that I would broadly call kind of climate change adaptation, and I'm trying to understand some of the social behavioral aspects of adaptation to the water resource implications of the changing global climate. And so I thought what I would do today is sort of give a broad overview of those issues as I see them, and then try to kind of weave in these 2 areas of my recent research as well. Okay, so what does climate change hold in store for water resources? Well, there are lots of things. There are many people in the room that probably know more about this than I do, but what I read, right, suggests both increased frequency and magnitude of extreme events, things like droughts, floods, or even sort of less extreme events like, very heavy precipitation events and so on, that many communities, states, regions, countries are having a hard time dealing with. The cyclone in Vanuatu recently, may or may not be empirically linkable, right, to anthropogenic climate change, but those kinds of events, at least it's sort of consistent with the theory that those kinds of events might become more frequent and more extreme. And then, of course, cause more extreme damages as a result. And then there's also those sort of slower long-term shifts, in kind of mean precipitation, temperature, humidity, wind intensity, the duration of snowpack, right, spring coming earlier to places and so on, nature and extent of vegetation, soil moisture, runoff, all of these things affect the sort of amount of water available in a particular quality at a particular place and time in a particular quantity, and that's going to have some pretty important economic implications. And then related to that, there are behavioral shifts that we expect to happen, and certainly are already seeing manifest today in terms of demand for heating and cooling, which has implications for water demand and supply, changes in demand for irrigation, and so on. Right, so both the behavioral and the physical aspects of these changes are already manifest in some places. So there are a lot of folks that have written about this, right, these kind of hydrological implications of climate change. This is just one map showing sort of distribution of what might be expected to happen in terms of mean kind of per capita runoff. And in general, the story is that global per capita runoff will increase as temperature rises. So you'd say, well, that's maybe a good story, right? The atmosphere is hotter, so there's sort of more moisture available. But the increases actually will occur mostly in East and Southeast Asia during what are already the high flow seasons, right? So again, there's this sort of problem at both ends of the spectrum in terms of scarcity, increased scarcity in some places that look more orange and red on that map, increased availability of resources in areas that look more kind of blue and purple, but maybe at the season when it's most difficult to handle those increases in availability of water resources. And there's still a fair amount of uncertainty in both the physical impacts, especially if you're talking about sort of looking at a regional scale or even a local scale, right? Downscaling from those global climate models, what might happen in an individual place at a particularly important time is a hard thing to do. And there also is a lot of uncertainty on the behavioral side about exactly what those implications might be. And I think on the behavioral side, we have even maybe more uncertainty because I think they're less well studied than the implications on the physical science side. And really it's the combination of these two things, right? What the physical impacts will be on water resources and how people react and adapt or not, as we'll talk about today, to those impacts that are going to determine the economic impacts, the implications of climate change for what we think of as economists as sort of welfare, sort of social welfare. And so my perspective is that there's, it's always nice as a researcher to say, well, we need more research, right, in my area. So this is sort of the message of the talk in some ways, right, that we could really use a lot more research on some of these behavioral impacts to understand exactly what might happen and how we might plan for that in a policy context. So I could make a long list of things that I could talk about in a discussion like what we'll have today, right? Those kind of climate impacts we're talking about will affect health, agriculture, urban and industrial, water supply and demand, transport, energy supply and demand, lots of different angles there. I'm really just going to touch on a few important issues. The first one will be kind of what are those adaptation costs? What do they sort of look like? Has anybody tried to sort of quantify that empirically and understand the scale of those costs? And mostly there I'll be talking about kind of diverted non-agricultural uses, because that's the focus of my own research, but kind of keep in mind in the back of your head that agriculture is a really important piece of the picture here, as we'll get into later, because around the world the fraction of water, sort of water consumption and water withdrawals by agriculture is actually very, very high relative to other sectors. And that'll sort of play an important part in the discussion later on. In addition, I'll talk about changes in water supply and demand that we might think might function kind of through markets, right? If so, we can imagine things get drier, people begin to rethink some of the current allocations in the western US and western Canada and other arid regions. You often have a lot of water rights in agriculture, sometimes 80 to 90% of those water rights in agriculture. And you could imagine more pressure, and we'll talk about why that is in a few minutes, sort of more pressure to move some of that water into municipal uses and sort of higher valued uses. Or you could imagine, right, places, sort of, and that would suggest a movement toward market allocation. You could also imagine water rights discussions sort of politically and socially becoming much more difficult as water gets scarcer, and maybe that's less of an incentive to move toward markets. And so we'll talk a little bit about that too. And then finally, I want to spend a little time talking about water supply infrastructure, because when we think about adaptation to climate change, often we're thinking about sort of constructed, right, sort of man-made projects like dams and reservoirs, right? After all, we come up with those kinds of solutions to smooth that sort of natural variability in water supply. And if that's increasing, maybe we can just increasingly rely on these kinds of infrastructure investments. And I want to talk about some reasons why I think that might not be necessarily as easy as one might think ex ante. So I'll talk about that, and especially focusing on transboundary settings in which people are sort of sharing river resources, for example, across international boundaries, and even to some extent within international boundaries across more regional boundaries. Those can get kind of tricky. Okay. So let me first start by telling you a little bit about what we know from economic estimates sort of using integrated assessment modeling, right? These sort of models that combine models of the physical climate with that of the economic systems. Sometimes at the global level, we see that certainly used by organizations like the IPCC when thinking about predicting climate change impacts and impacts on economies. But these are also done at local levels, and the ones that I'll talk about here, there's sort of one example from the national level in the United States. So back in the 1990s, as people were doing more and more research on climate change, there's a group of researchers that was working on trying to understand and sort of quantify empirically these water resource implications, right, for the US economy. Okay, and so they first took a very simple approach where they said, well, the average runoff in the United States is going to be reduced by X, and the average cost of using that water in the United States is Y, and so I'll multiply X by Y, and that gives me the kind of economic cost of the hydrological implications of climate change for the US economy. And that is very simple for a lot of reasons. One is that you could imagine, I mean, again, if water is moving sort of perfectly through markets, that is, it gets more scarce, the price should rise, that should reduce demand. It should also increase incentives for people to develop new desalination technologies or other technologies that help us use water more efficiently or use lower quality of water from different kinds of sources. And all of those kinds of substitution effects and so on should really kind of be integrated into any analysis like that, because otherwise we could really get a sort of skewed picture, right, of what the impacts on the economy might be. And so in some ways, those early studies were just sort of too simplistic, right? They assume essentially no what we would call adaptation, right, through markets. And then there are some more recent efforts focusing more regionally, okay, looking at individual river basins like the Colorado River system in the United States that are expected to have pretty significant impacts from climate change in terms of reduced water availability. And so people have modeled some of those major basins assuming basically the opposite end of the spectrum from what these guys assumed, right? Instead of saying, okay, there is no effect on prices or demand or supply or anything, instead we'll just assume all the water gets moved to its highest valued uses, right, instantaneously and efficiently. And so, right, we have this sort of dynamically efficient water markets that are functioning. And so then, as a result, you wouldn't be surprised to know that the implications then of the water resource impacts of climate change for economies in those regions are kind of small, right, assuming that everything is going to function very efficiently. And so then I would sort of say, well, the problem there is, well, where are, right, in the water sector, where are those markets and those efficient prices that are assumed in those models that are going to get us to that nice and sort of satisfying outcome? And so you have to think about these two different classes of models as almost equally naive, right? One says, right, this is really disastrous, the costs are relatively high because there's no adjustment. One says there's perfect adjustment. And really probably what we'll see is something that's in between. So when I say there's a need for more research, it's in this kind of in-between area, right? What do we think that real institutions that allocate water resources now in important places that will be affected by climate change will do, right, as the climate changes, right? Do we think we'll see more markets, fewer markets, right, higher prices, lower prices? And that's what I'm working on now. Okay, so when I say where are those water markets and prices, I want to sort of give you a sense for where we tend to be, right, in industrialized countries, and even to some extent in developing countries. We'll look at some data for those in just a minute. And when I say water prices, you know, you have to think about the price in most markets as the key signal, right, for the value and use and the scarcity of a good or service. Okay, so if it's, you know, the dead of winter and I live in New England or I live in, you know, in Ontario, and you know, it's very, very cold and people are demanding a lot of heating oil, then the price of heating oil goes up, right? And my bill goes up, and then maybe I turn my thermostat down a little bit and I wear a sweater, right? We sort of respond, we know that we respond to those kinds of price signals. And in the water sector, it's very, very different, okay? Your water price is generally pretty static. It doesn't change very much over time. It's set by usually some kind of administrative body, or at least governed or regulated by an administrative body. And it's not necessarily going to go up and down depending on how scarce water is, right, or what kind of use you're putting it to, okay? And so I'll give you some examples of that. There's an organization called Circle of Blue, and I like to kind of take graphs from some of their work. They've done some nice work on this. And this is going back to 2010, but the situation is pretty similar even today, 5 years later. And what I'm showing here is data from 5 different US cities. So Las Vegas is on the far left over there, and then Phoenix, Arizona, Boston, Massachusetts, Milwaukee, Wisconsin, and Santa Fe, New Mexico. And some of these are really dry places, and some of them are really wet places. And what the bars here on the graph are telling you is the sort of orange, the brown to orange to yellow bar is the average monthly bill, water bill, for a family of 4 in one of these cities using 50 gallons per day. That's this kind of dark brown bar here, gallons per person per day. This is the average monthly bill for the height of this bar is the average monthly bill for a family of 4 using 100 gallons per person per day. And then the yellow piece of that is, again, going one step up, right, for using 150 gallons per person per day, right? So the average bill goes up with how much you consume. And so the sort of total height of that bar is that you know, average bill for a family using about 150 gallons per person per day. The green bar tells us something about consumption, average consumption in that city. Okay, so this is average daily per capita residential use. It's just the residential sector in gallons, because this is US data. And then the blue bar tells us something about supply. This is average annual precipitation in centimeters. It's a little odd, right, to mix those two, but that's okay. All right, so I've got some sense of the natural supply, some sense of how much is demanded, right? And the price, if this were a market, would be helping us to sort of equilibrate those two, right? The price would be saying, hey, this is a place, Las Vegas, Nevada, extraordinarily dry, it's in the desert, right? You literally, to grow a lawn in Las Vegas, you have to put about 5 feet of water on your lawn per year, right? For every sort of square inch of your lawn. And so this is a place that has very, very low renewable supplies, and yet, right, a huge amount of consumption. And what you can see is relative to some of these other kind of wetter cities, the price is still pretty low. Okay, it's not really giving us this signal that this is a really scarce resource, a scarce and valuable resource, and we shouldn't necessarily be putting 5 feet on our lawn, okay? And then we sort of move from left over toward the right. Phoenix is a very similar story, right? Low supply, again, it's a desert community, so low supply, very, very high demand, pretty low price. Again, the price is sort of failing to serve that function of trying to sort of bring demand and supply a bit more into equilibrium. And then you can sort of keep telling that story. Boston's actually pretty wet, right? But the prices are pretty high relative to these other cities. The only one where things really seem to make some sense are these guys over here, right? Milwaukee having a pretty pretty high mean renewable supply, demand not too high and the price is fairly low. And then Santa Fe, another very, very dry community, desert community with low supply, somewhat higher demand and very high prices, trying to kind of bring that back into balance. And so this is not perfect, right? There's no analysis here. I would have to, I've done lots of demand estimation. We could do lots of fancy empirical modeling, trying to understand how sensitive people are to prices in these different cities. But the basic message, right, is that the price in a lot of these places is not capturing, right, the scarcity, certainly, and also to some extent the value in use. And we'll talk about value in use in just a minute. Okay, so in that context, those optimal adaptation models that say, right, there's a market, there's a price signal that's going to cause water to flow to its highest value uses are equally as naive as the no adaptation models. And I'll give you some just anecdotal examples of this stark contrast between actual real world sort of water allocation and prices and what would be the optimal allocation. So if you look at the US West, you can find communities that are very close to each other that are paying wildly different water prices just depending on the use to which the water is put. Okay, so in the city of San Diego, California, the city residents are paying about $225 per acre foot. This is, I think, in some ways, a uniquely American way of sort of measuring large quantities of water. It's the amount of water that would flood an acre of land to a foot in depth. Okay, this is the sort of how water trades are actually denominated in the Western U.S. So the residents of the city of San Diego are paying about $225 per acre foot, and then the Central Valley farmers that are using the same water resource, and sometimes actually the farmers are selling water to the residents of the city of San Diego, they pay $15 to $16 per acre foot. Okay, so there's very, very dramatic differences in the price of using water that's going to drive, right, the value to which that water is put, and I'll show you some examples of that in just a minute. Similarly, in Arizona, so Pima County, Arizona, the farmers are paying about $27 per acre foot. Nearby, the city of Tucson, which is again sometimes buying water from farmers, is paying almost $500 to $3,300 per acre foot. So very dramatic differences in prices. And we see the same thing in Texas. For the most part, agricultural users paying much, much lower prices than what we see in the municipal sector. And so why is that meaningful? Well, what ends up happening, I promise this will be the only demand and supply graph that I'll show the entire talk. What's happening is if you think about sort of a total water supply that we have to allocate to anybody as being the length, yikes, go back. Okay, as being the length of this horizontal axis down here, right? I have some total, imagine it's any given year, I have a supply that comes from nature and I get to allocate it between two groups of users, okay? Agricultural users who are the green demand curve here and municipal users who are represented by the blue demand curve here. And I can choose any allocation that I want, anything from the cities getting nothing to the cities getting everything, right, to agriculture getting nothing to agriculture getting everything. So they're kind of moving, their quantities are moving in opposite directions on that horizontal axis. So what would happen if I had a market? What would happen is that I would have this market sort of clearing price, and it would be a single price, and it would happen right here, okay, right where the kind of value of water represented by the height of that demand curve in agriculture is exactly equal to the value of water represented by the height of the demand curve for the cities. And this height right here, the height of the intersection, would be the kind of would-be market clearing price for some scarce water resource, right? Scarce because we only have, right, from zero to the total supply to allocate to these two sectors. But instead, what we tend to have in a lot of dry places is we tend to have allocations that look more like this, okay? Where agriculture gets a huge amount, right? So if you're sort of moving this way from zero to the total supply, right, we're giving, say 80% of our water supply goes to agriculture, what's left over goes to cities, and so that's in part what's driving those huge difference in prices that you just saw earlier, right? We've got a very, very low price for agriculture, we've got a high price for cities, and as a result, that kind of gap that opens up between the two of them, between the price paid by cities and the price paid by farmers, is driving this pressure to move water from one sector to the other, right? I've got all this high-valued uses in the cities, I've got low-valued uses in agriculture relative to what I would see if the allocation were back right over here, closer to their intersection. And so as a result of those big different prices, I have this huge gap in the value of water that's used in the different sectors, right? And intense political pressure for reallocation. You read a lot about this in the Western US, this pressure. The cities really want more water. The farmers don't want to give it up. There's sort of a lot of political tension over over that very problem. And we're not alone in the United States in this phenomenon, because this inefficient water allocation that results from these different prices, dramatically different prices in the different sectors, is pretty common. So what this is showing, this is back in the late 1990s, some data from the Organization for Economic Cooperation and Development, showing both agricultural prices, average agricultural prices in dollars per meters cubed. Average industrial prices is the white bar, and then the lighter blue bar is average municipal or sort of residential prices. And this agricultural bar, this darkest one, the first one, is really only visible even, right, for the Netherlands and for Austria. And then by the time we get to France, the rest of us, including the United States and Canada down here at the end, are charging very little, if anything, for agricultural withdrawals, okay, from common sources. And in contrast, right, this lighter blue bar is pretty big, right, certainly relative to agriculture. Okay, there's some variation, it's small in some places, but for the most part, those urban prices, those municipal prices, are very much higher than what we see for agriculture. Okay, so what can we do in that situation? We have most of the water that's allocated to agricultural uses in a lot of dry places. We don't have a lot of water allocated to urban uses. There's this pressure to change because of high value in one market and low value in the other. And so one thing that could reallocate would be some robust water markets, right? You could allow farmers to sell to cities, for example, and we'll look at some data for what happens when we allow that in just a few minutes. And then maybe we could get closer to what these second class of naive models is assuming, right, that we'll have this dynamically efficient allocation happening as things get drier, potentially get drier. And in fact, we have seen that. There are some places, dry places around the world where we've got some reasonably robust water markets. So the Western US is one example, but Chile and Australia are two others. Australia probably has the most active water markets in the world. And so my question would be, well, how would that then evolve with climate change, right? Is that one potential adaptation mechanism, right? Could we take this situation where we have currently inefficient allocation, things are getting drier, that sort of length of that horizontal bar is shrinking maybe in some places, and now I need to know, right, what the losses are from that inefficient allocation. Well, maybe if that causes pressure to develop more markets, maybe we can fix that problem to some extent. And so there are sort of differing views on what might happen here. So I have a colleague, Gary Leibkap, who's at the University of California, Santa Barbara, and he's pretty skeptical. He's done a lot of work on water markets. I'll show you some data from some of that work in a few minutes. His sense is, look, these historical water allocations are locked in over time. They haven't moved very much. The institutions seem to be pretty inflexible, and they don't seem to adjust very easily to new circumstances. So he's sort of, I would say, sort of a skeptic about how far that will go to help us out. And then another environmental economist, John Loomis at the University of Colorado, says, well, I don't know, maybe not, right? Maybe this increasing scarcity in some of these arid regions will finally kind of break, right, this resistance to allowing water to flow between sectors, right, and sort of change those or reduce those restrictions on the freedoms of water rights holders to seek, right, purchasers that could put the water to higher valued uses. So I think there's kind of a mix of views on that. I'll kind of show you where we are, at least in terms of the markets in the Western US. This is some data that Gary Leibkap, again, back in 2008, gathered with some colleagues between 1987 and 2005 on just kind of what's happening with that trading. And this top bar here, this squares, that's just telling you the total number of water transfers, right? So from 1987 to 2005, and what you see, okay, it's bouncing around a little bit. For the most part, that trend is up. Okay, we seem to see more water traded over time across these 12 states in which there's some trading happening. And most of that trend, right, it's not down here, right, in the urban to urban trades or the agriculture, the sort of farmer to farmer trades. Most of that action is in these sort of white triangle series here, right? That's where most of the climbing is happening. And those are in the trades from agricultural sources to urban, okay? So it's sort of telling you if you open the doors and you allow some of this trading to take place, right, the market is going to do what you might think it would do given those big differences in prices that we saw, is the water is going to start to move out of the farming, right, and into the municipal uses. I'm looking with two colleagues, my colleague Karen Fischer-Vanden at Penn State and her PhD student Renata Rimsaita at Penn State as well, at these same data and trying to do some additional work thinking, okay, what have been the welfare implications, right? How much economically has that improved? Has that movement of water through these 12 states markets improved, right, the economies in those states over time. And we're finding very similar patterns, at least in terms of just simple summary statistics. And what this is showing you over here on the left is that those water transfers kind of to the urban sector, that blue, the height of that blue bar, in many of those states, that's the really kind of important story, right? And then similarly, if you kind of look at the different kind of pairs of trades and the prices of trades, we see this pattern where the prices of trades going from farms into cities is really quite high, right? Prices of many trades going into agriculture are really quite low. So we do see patterns in the existing markets that are consistent with the story that markets can help be sort of one adaptation tool, perhaps one of many. The downside, right, or the potentially bad news, is that even in the states and places, other places around the world where we do have a lot of trading taking place, it's still a tiny, tiny fraction of total kind of water withdrawals or water consumption in those places. So I'm just picking out 3 examples here. These are 3 US states that have particularly active water markets. So Texas, my own home state, California, and Colorado. That's the left-hand column here. And then I picked out from the US Geological Survey, does a survey every 5 years of water use in the United States, and it tells us a lot about, right, water being used in different sectors and different states and counties. And so their 2010 estimates just came out at the end of last year. And so they estimate that in thousands of acre feet, agricultural withdrawals in Texas were, right, about 7 billion, is that right? 7 million acre feet. And you could sort of read on down the columns in terms of these other quantities. California being an enormous state, right, has lots and lots of agricultural activity, has very high agricultural water withdrawals. And then you compare that to the sort of thousands of acre feet that we in these data, right, on water trades actually see traded to agriculture, right? And this is telling us this is how much water the agricultural sector withdrew in these states in 2010. This is how much water agriculture purchased either from other farmers or from cities in 2010. So tiny, tiny, tiny amounts. Okay, then you'd say, well, yeah, but agriculture isn't where all the action is, right? Because they're not necessarily going to buy a lot of water because that's where a lot of the low-valued uses are. Maybe it's the cities that are buying all that water. And you're right, that's true. Okay, in 2010, this is the US Geological Survey's estimates of water withdrawals, right, for Texas, California, and Colorado in thousands of acre feet. And in 2010, these are the numbers that we come up with in terms of what's the total amount of water that was traded to cities from other places in those years, okay, in that year. And again, it's really, really tiny, okay? Probably the best scenario here is in Colorado, where urban areas used about 950,000 acre feet of water in 2010, and about 42,000 of those acre feet came from, right, purchases on a water market. And so between 4 and 5%, right, of urban consumption actually is, right, the result of trading, water trading of some kind. So that suggests, right, that even though we do have these markets and they seem to be functioning, right, if you sort of look at those pictures of water moving out of, ag into cities and so on, they seem to be functioning the way we think a market should. They're still only functioning for a really tiny, sort of fraction of total water withdrawals. And so we'd probably need a lot more movement in that sense, right, sort of toward markets to think that this is going to be a really effective adaptation mechanism. Okay, to shift a little bit into thinking about other adaptation mechanisms, right? I said, how do we smooth this kind of variability in water supply? Well, we build dams and reservoirs and distribution systems, irrigation systems, and so on. And that really is the main purpose of that kind of investment, right? We're trying to sort of reduce our sensitivity to our vulnerability to weather shocks, right, that are potentially increasing with climate change. And the need for that is likely to increase. So there's certainly some work. I have a colleague named Wolfram Schlenker who's at Columbia who's done a lot of work on irrigation, agricultural irrigation. And he can show that that's very sensitive to climate, right? That it tends to be true that on the whole in places where it's drier or you're more likely to experience a drought, it's also more likely that farmers adopt irrigation systems. So to some extent that's good news, right? That tells an adaptation story. If I think the climate is getting drier, then I'll have more farmers adopting irrigation, and that will somewhat mitigate, right, the negative impacts on crop yields and so on from the changing climate. And so that suggests that infrastructure may play a role in other sectors too, right? That's an interesting kind of thought experiment. What will happen in cities as it gets drier? Will they build more dams and reservoirs, right? They're not irrigating per se, although a lot of that water does go to kind of suburban lawns. But right, for all of those urban uses, are we going to try and kind of buffer our experience with respect to climate change by building more infrastructure? So what would be some examples of that? I could have groundwater recharge and storage infrastructure. Certainly places that do that. El Paso, Texas has a big sort of aquifer recharge program. I could increase reservoir capacity, change reservoir operations, right? I could raise dams, I could remove sediment, I can lower water intakes. We're talking about doing that in some very big reservoirs in the United States where prolonged drought has really reduced the levels of the important reservoirs. I could increase reservoir size. I could take green infrastructure approaches if I'm worried about these extreme precipitation events. Right? I could preserve open space and do other things. I could protect or relocate low-lying existing infrastructure like water treatment infrastructure, wastewater treatment plants, and so on. So there are a lot of kind of adaptive things, investments that local sort of cities and regions can make to make sure that, right, we're sort of trying to be reduce our vulnerability to climate change as much as we can. Again, here's a place where there's some, I think, reasonably thin empirical evidence on if and how this will work. Okay, really, I can only find one sort of careful paper in the literature, and maybe those of you here can point out some others for me in the Q&A, where people have even tried to think about, well, how much will that cost, right? Let me think about what the physical implications of climate change will be hydrologically, what would be the sort of necessary responses to reduce or even eliminate some of the impacts of those economically, right, in terms of infrastructure investments. And so this group of co-authors in 2010 in a journal called Utilities Policy came up with some engineering cost estimates of the kind of adaptive infrastructure investments that would be necessary for OECD countries. And they included things like the cost of water supply, water treatment, sewage treatment for residential, commercial, and industrial use. So there's no agricultural story to this part at all. It's really just focused on these kind of urban questions that I said we still have a lot of uncertainty about. And what they come up with when they do this is that these adaptation costs, these kind of necessary infrastructure investments in terms of the pure engineering costs, are less than 2% of the total current baseline water infrastructure provision costs in OECD countries. So that sounds small, right? It sounds like we just have to make this sort of small investment. And then on the upside, from an economic perspective, they say, and if you raised prices in response to increased scarcity or an anticipated increase in water scarcity, you could reduce those costs very dramatically. Even from that small baseline, you could reduce those costs very dramatically, because if you just increase the prices, people's demand will go down, and then you don't need some of that additional reservoir storage capacity and so on. So to some extent, that's a sort of a positive message. But again, I want to sort of think a little bit more broadly about how these kinds of investments work, and particularly when I think about transboundary resources. Okay? Because water resources, things like rivers, shared rivers, present kind of classic common property problems from an economic perspective, and we have to think about how that plays out when we go to a sort of drier, scarcer situation. Okay, so what do we know about this already? Well, we know this is a significant issue. Okay, so there's 261 international river basins that cover about 45% of the Earth's surface, just in terms of the watersheds themselves, not just the water courses. And we also know that there's actually some really nice evidence, well, nice empirically, but not so nice from a policy perspective, that countries tend to try at least to export pollution to their downstream neighbors. Okay, we see that, and so Hilary Sigmund, my colleague, and I'll be talking about some joint work that we're doing in a few minutes, back in the sort of early part of this last decade, was able to show that countries tend to do this. She did a global analysis. She did analyses just for the European Union and other places, looking at whether countries in fact seem to engage in this, right? Do we see, all else equal, pollution concentrations higher sort of at and near borders than elsewhere? And she showed that in fact we do, and she also showed some mitigating impact of treaties or sort of cooperation. Okay? So these effects seem to be smaller in the EU, for example, than they were in other parts of the world. And then Molly Lipscomb and Mushfiq Mubarak have a current paper showing that this is the case in Brazil, that if they looked at sort of changes, a set of administrative changes that happened in Brazil, and a bunch of county boundaries changed, and they show actually that this kind of export of pollution is affected by these changes in boundaries, which is a really nice analysis too. And there are other papers that show this as well. So empirically, we have a lot of proof, I would say, in environmental economics that this tends to be a phenomenon. Okay? Countries try to export pollution to their downstream neighbors. And in fact, I would say that even some additional analyses by Hillary in particular shows that happens even within the United States between states. Okay, so this kind of existence of an administrative boundary seems to make difference in terms of how people think about the welfare of the folks on the other side of that boundary. Okay. We also have anecdotal evidence that countries tend to do this kind of free riding, right, have these common property problems in water allocation. Okay, I'll give you some anecdotal evidence in a few minutes. There's also support for this in theory. Most of that has to do with non-renewable groundwater resources. There's a lot of work thinking about sort of optimal groundwater extraction, taking into account the fact that when I deplete groundwater over here, I'm affecting, right, through a cone of depression or some other phenomenon, affecting groundwater availability over there. So there's a lot of work that would suggest maybe that there are these common property problems when we come to water quantity, not just water quality. And the recent work that I've been doing suggests that this exists on a global scale in transboundary river basins, okay? And my concern is that climate change could potentially exacerbate this problem, and I'll talk about why in just a minute. So the example that we use in our current work, and this is work with Hilary Sigmund at Rutgers, it was partially funded by the World Bank, is that as background, the sort of implications of these water resource investments, this water development projects like dams and so on, are kind of complex. So there are a lot of services provided by a dam and a reservoir that it might impound, okay? So this is why people build them, right? I can increase my water supply, I have water availability for irrigation in a much more predictable way, I generate hydroelectricity, I can have some flood control benefits, I can improve fisheries, recreation, and so on. So people build dams for lots of reasons, lots of purposes. But they impose costs as well, okay? So I can reduce the flow of water available downstream, I might change the timing of it, I might change the temperature, the magnitude of seasonal flows, I can hinder the movement of fish and other species. This is a big issue in the United States, in the Pacific Northwest in particular, when you think about endangered species like salmon. I can change the rate and quality of sediment deposition downstream. So I have a lot of downstream costs, some upstream as well, but what we focus on in our current work is the downstream costs. And interestingly, economists have started to look at this, and there's a really interesting paper in what's called the Quarterly Journal of Economics, a major economics journal, looking just at India. Okay, so Esther Duflo and Rohini Pandey do a paper in 2003 where they take dams that are built in India, and I think maybe it's since 1960, I can't remember the particular dates, and they say, okay, I know that I generate these local benefits, you know, for example, I'm providing irrigation water and reducing vulnerability to weather shocks for these farmers, right, in the sort of catchment area of the dam, in the command area of the dam. But upstream in the catchment, I may have some negative impacts. I might have resettled populations, I might have some waterlogging or salinity in agricultural soils. There's all kinds of potential sort of impacts in other affected areas. And they try to quantify economically both the sort of upsides for the affected people that benefit and downsides for the affected people that lose. And they find that in India over this period of time, approximately the losses outweigh the gains, right? Which would suggest that even at the national level, right, while we have some pretty intense local economic benefits from this activity, if we sort of add up all the winners and losers, we might not be really improving pictures, at least in the way that these things have been constructed in the past. And there's, again, plenty of examples for that for individual water development projects in many, many countries. Okay, that's true for projects that were built back in the 30s, the 40s, the 50s, the 60s, and for projects that were completed in the 1980s and the 1990s. So individual kind of benefit cost analyses would suggest, gee, maybe, right, the winners don't necessarily outweigh the losers. Okay, so my concern, or our concern that we're working on now is additional to that. Okay, so the Duflo and Pandey analysis sort of stops at India's borders, right? And it says, within a country, do we sort of optimally place these things? Do we maximize net benefits from water resources, or are we sort of causing a net loss? And our concern is that countries that are sharing a river have an incentive, just the way they do with pollution, they have an incentive to sort of pass off some of those downstream costs of dams to their riparian neighbors. Or, you know, you could also think, well, maybe if I have a flood control dam and there are some downstream benefits, I'm not necessarily going to count, or I'm at least going to partially discount any benefits that would accrue outside of my borders. Okay, so you could imagine both cases, which would both kind of bias this sort of dam location relative to what would be optimum. And so our work in progress looks at this question, right? Do countries sort of free ride in water diversion on these international rivers through the placement of dams, the size of reservoirs, the height of dams, and some other interesting outcomes? And then we look at whether some things that you would think would mitigate that behavior, things like, well, gee, the World Bank funded this dam, and they should, at least right in theory, have in mind the welfare of surrounding countries more so than the individual domestic country does when they're making that investment. So maybe that mitigates things in some cases. And then certainly treaties, right? International river basins, many of them have treaties for lots of different things, including water allocation. Some countries actually cooperate on infrastructure, building and management, and reservoir operations, and so on. So we can imagine that treaties could also mitigate that kind of common property problem. So we look at all of those questions. This is just some of that anecdotal evidence that this problem of sort of water sharing might not necessarily be approached with a sort of collective action framework in mind, right, relative to more of a competitive framework, right, or the common property kind of framework. Okay, so there are plenty of these that we could cite, but I picked just two. One from coverage about the Renaissance Dam in Ethiopia. So the Nile flows starts in Ethiopia, flows through Sudan and into Egypt. and provides a very significant portion of Egypt's water supply. And there are estimates out there that Renaissance Dam that's under construction in Ethiopia will reduce the amount of water flowing down the Nile into Egypt by about 25%. So that's really important, right, for the country of Egypt. And these guys are going back and forth about this. This is a 2013 quote from former President Mohamed Morsi. And he said, right, we will defend each drop of Nile water with our blood if necessary. Again, not necessarily implying, right, sort of a cooperative approach with its riparian neighbors. And then similarly, former Chinese Water Resources Minister Wang Shucheng described his nation's water policy being questioned about this, right, while discussing sort of governance of China actually has part or all of, I guess, part of at least 13 major transboundary rivers. And there's a quote here, right, he says, you know, they said, well, sort of what's your policy with respect to these rivers? And he said, well, to fight for every drop of water or die, right? That's the challenge facing China, right? Many of us may have read about some pretty severe water availability constraints and water quality constraints faced by China. One can understand the perspective of an individual country, right, in both of these cases. And at the same time, you worry, right, that if the solution to some of these increases in scarcity or changes in increases in variability of water supplies is building dams, that these sort of problems of collective action or common property problems may gum up, right, our ability to really do that in a way that makes the picture better rather than worse. So Hilary Sigmund and I have put together these data and are sort of running some analyses right now. We're using a database that's actually managed out of the University of Toronto and many collaborating institutions called the Global Reservoir and Dams Database. We use almost 5,000 geocoded dams from that database, placed in just under 3,000 what we call sub-basin country areas. It's kind of the intersection between country borders and a sort of middling level of designation of a watershed using USGS's Hydro 1K digital elevation model in 381 major river basins. Okay, and so 115 of them are international. They're shared between two or more countries. And then 266 of them are exclusively domestic rivers, okay, not flowing outside of any country's borders. So these are just two maps, a map of Asia on the left and Africa down here on the right, showing the sort of data that we're using in the analysis. And we use a regression-based approach, and we draw some preliminary conclusions from that work that controlling for things like lots of different physical characteristics driving sort of physical suitability for damming, demand captured by population growth and other things in these areas. When we control for a whole bunch of stuff, the basic model suggests that you still get about 27% more dams than you would anticipate, right, all else equal, in sort of upstream of downstream riparian neighbors, okay? Suggesting more dams in international basins, right? If I had a choice as to where to place this, I'm going to tend to place it upstream of a neighbor because I can at least partially discount the costs that are going to be flowing downstream. And that's consistent with some pretty significant common property problems, right? That suggests that countries aren't necessarily fully considering the welfare of downstream neighbors when they're developing these water projects. So then again, we look at, well, what happens if the dams receive World Bank funding? And we do find that in those projects, right, if we just look at those dams, that does seem to mitigate that common property effect, okay? So we reduce from about 27% more dams to about sort of 10.5% more dams when we're thinking just about the ones that are funded by the World Bank, so a somewhat mitigated impact of that resource sharing. And in fact, if you look just in the sort of subbasins that are really close to the border, ones that for the next downstream subbasin is at least partially within another country, then that impact of World Bank funding takes the sort of common property resource sharing problem down almost to zero. So it's more like, you know, sort of 3% range. So that's kind of an interesting story, right? That if we have an outsider kind of involved and thinking maybe a little bit more about the region than just about the individual country, maybe we mitigate that. We find it's hard to say, you know, one of the problems with looking at whether treaties are really effective in dealing with this is that there's a lot of evidence that treaties tend to just kind of formalize an underlying propensity to cooperate, okay, rather than really doing something to improve cooperation over a resource or some other element of sort of potential conflict between two countries. And so we kind of have to deal with the problem that treaties tend to arise either in places where there already is a problem or places where there really isn't any problem, and so it's very easy, there's very low cost, right, to conclude a treaty. And so we have to sort of take some careful statistical steps to deal with that problem. And in addition, of those 115 or so international basins in our data, about 80 of them have one treaty or another that has something to do with water resources. And so that's a real small numbers problem, right? I'm comparing river basins, really only 115 could even have a treaty, 80 of them already do, and I'm comparing sort of groups of very small numbers. And so when I say we find weak evidence that treaties mitigate free riding, it's kind of both good news and bad news. On the one hand, we don't find strong statistical evidence. I sort of say weak statistical evidence that that common property problem, that resource sharing problem, tends to be, sort of less bad when we have a treaty in the basin. On the other hand, I don't know that one could find strong, sort of large N quantitative evidence of that, and the kind of analysis that I tend to do, that we've been doing, because of this small numbers problem, right? So if you looked anecdotally, if you had more of an anthropological story, or a story that was a little bit richer, and you could go back and you could pull a bunch of quotes that are different from those sort of Egyptian and Chinese quotes I showed you earlier, you might find a little bit of a more kind of comforting story about the potential for treaties to mitigate this problem than what we've been able to find in our statistical work. Okay, so that's a little bit of a sort of hanging issue for us. But again, kind of like the water market story, what I want to know is, as the climate changes, what's likely to be the effect, right, of that on these sort of infrastructure investments and the way that countries think about infrastructure. So on the one hand, if you look at the legal literature, it suggests that existing treaties tend to be pretty rigid, pretty long-lived. There's some evidence from things like, for example, the breakup of the former Soviet Union, that countries that were either directly involved or affected by that, countries like Hungary in particular, tried to sort of change some river basin treaties that were, where its needs were dramatically altered because of these changes in country borders and changes in sort of political economic changes that were happening around it. And those countries were not able to make those kinds of changes that they really wanted to, right? Because the treaties were already in place, and the kind of cooperating countries were not willing to change their stance given the change in circumstances for these other countries. And so that would suggest that, right, going forward, it's sort of hard to change those kinds of institutions. They're pretty static. They tend not to be super adaptable. So if we worry about that, right, we say infrastructure is important, but we really need, in these transboundary cases, we really need some treaties. You'd sort of say, okay, well, if you really want that to be climate responsive, you're going to have to set that up ex ante, right? We ought to be thinking about that now before the climate changes and there are winners and losers, and somebody's trying to go back, right, and regain something that they've lost, and it involves taking something from somebody else. That's a little bit of a harder problem. So to some extent, that sort of is reminiscent of the water marketing problem that we're seeing, right? Okay, we see these markets, they're there. Maybe they can function pretty well as things get drier, but right now all the rights are locked up in agriculture, and people are reluctant, right, to sort of really make that shift. There are winners and losers from that, right? And it requires some pretty careful thought about how those institutions evolve, instead of just saying, oh, well, this is not a problem because all the water will just come out of agriculture and go into the cities, right? Or this is not a problem because we'll just build dams and we'll have treaties to manage any transboundary problems. Anyway, those institutions tend to be a lot less flexible in practice than what we've seen in theory. All right, to sort of conclude, and then we can go on to some Q&A, there certainly is lots and lots of great physical science work on the water resource implications of climate change, right? There's significant, there's some uncertainty there, but I think, again, ultimately the impacts depend on these behavioral shifts. How do institutions evolve, right, to try and adapt to these changes in the global climate? Prices, markets, infrastructure, treaties. And the empirical evidence, I would say, on the whole, would suggest that these kinds of institutions don't yet support anything that's really close to what we'd think of as sort of efficient water management regime in terms of allocation and pricing and so on. And that suggests that adaptation is going to be more challenging, right, than what we would sort of write down on paper if we're just modeling this in a very clean sense. And in addition, I want to kind of keep in mind that maladaptation is possible too. And by that word, I really mean something, right, if it's true that as things get drier, you see more of what's going on between sort of Ethiopia and Egypt, or what's going on between China and its neighbors, than you do of cooperative approaches. We could have countries, right, or places, regions that sort of are grabbing more desperately at what's left, right, than sort of collectively thinking about institutions and trying to manage things more efficiently. So I think there is some risk also that institutions can make things worse rather than just not making things better, and it's something to think about. So if I was going to make some suggestions of things to kind of keep thinking about and working on in this area, I think what we really need is some really kind of rigorous modeling, probably interdisciplinary modeling of the economics, the political economy, the physical science of water management. Things like what's going to happen to the level and structure of water prices as the climate changes. What happens to we often don't use prices to manage demand when things get scarce in the water sector. We use other things, education programs, bans, in urban sectors, things like watering restrictions and so on. So there's lots of approaches that we use, and they tend not to be economically efficient or sort of cost-effective approaches. How will those things evolve, and will they work better or worse, right, in the changing environment? Legal property rights regimes for water, right? Will the fact that all the water is currently allocated to agriculture, will there be some shift? Is there pressure for that? Have we seen that before in places that are dry and getting drier? The extent of and the constraints on water marketing. Investments in water supply infrastructure, like the dams and reservoirs that we were just talking about a few minutes ago. In addition to building new stuff, we can just change the way the existing stuff is operated, right? Is that something that we see happening, right, as the climate changes in some places? And then finally, these transboundary allocation institutions, treaties, right? That, to me, involves a lot of work by lawyers and others who can tell us, right, how these things, or if they can evolve, right, the ones that are currently in place and the ones that might be needed to manage the problems like this discussions between Ethiopia and Egypt, right, or between China and its neighbors and so on. So those are my suggestions, and I'm happy to take questions about anything that I've talked about or other stuff as well.
Yeah, thank you. Very interesting lecture, Dr. Olmstead. An observation is that humans being what we are and human nature being what it is, things don't tend to change, especially in a system of a lot of inertia, unless there's something drastic happens, a significant drought. The Murray-Darling Basin in Australia is a good example.
Yep,
okay,
that
that's
is a good
why
one.
things have changed there. Do you think that if we were to start charging the true cost, okay, of water supply and water services, that would be shall we say, a more proactive way of starting to change some of these inbuilt resistance, okay, to these systems, and hopefully get out before the actual disasters and droughts, etc., happen.
Yeah, I think that's absolutely key. It's a great question because that's been a big area of my own research, is thinking about that and what that cost is, why we don't get closer to that. So I think that's really key. I think there are a couple of things that I would say. One is I certainly think that ought to precede some of these other broader approaches like infrastructure approaches, right? Because if you don't need it, it's kind of like that simple kind of engineering cost estimate that I was talking about earlier. If you can simply raise prices, right, and save a huge amount of money, right, avoid a bunch of investments that may eventually, as the whole distribution of right, sort of water events shifts, may not work that great anyway. I look at California, for example, that has, the whole state is plumbed, right? It's got a huge amount of infrastructure moving water from the typically wetter north down into the farms and cities in the south. And in this, very severe drought that they've been experiencing in the last year, nothing, right? And there's nothing moving to those farms and cities because they just don't have the water. So, you can build the infrastructure, but it's not flexible in some ways, right? In some ways it is, but it's not as flexible as prices. So I certainly would agree with that point. The only thing I would say is the one thing that we've left out, and I didn't talk much at all about it today, is in-stream uses. So we still, even if we were to sort of fix those agricultural and urban prices that I showed that graph for, and sort of approximately everybody was paying the value and use on the margin, and the prices were right, we still don't have sort of markets for ecosystem services and so on that would incorporate those sort of external costs of withdrawing those resources from rivers and groundwater and so on. And so unless we could do that, right, the pricing mechanism only goes so far unless we can incorporate those external costs. We have a question here. Sure.
Sheila, I really enjoyed your talk. You raised a whole bunch of questions and made some claims that I want to probe a little bit with you because they don't sit well with me. I was thinking, no, that can't possibly be right. But in two contexts, you suggested that people made decisions to externalize costs to pass them on to their neighbors. One was location of dams, and the second one would be location of industries. And in both of those cases, I in my own mind, I just see a whole shopping list of reasons people would locate an industry or a dam somewhere. That comes way ahead of those things.
Absolutely,
The dam one, for example, when I think of Western Canada, 2/3 of Canada's irrigation is located in one province in Alberta.
Yeah.
They had the location of every dam in Alberta that is built and could be built in the south was scoped out in the 1890s
Yeah.
before there were any provinces.
Right. Yeah.
Right? So before you could even make the decision, I'm going to put it here to screw my neighbor downstream.
Yeah.
The neighbor didn't even exist yet.
Right.
Right? So what's with that?
Okay, so a couple things. So first, I completely agree that there's lots of stuff that goes into where should I locate a dam, right? And and I didn't get a chance really to talk much about the actual empirical analysis, but we're controlling for lots and lots of those things. Okay, so I'm pretty confident that we're not, leaving out what's the best place to put a hydro dam and that kind of thing. Okay. But let me also be clear. So I have to be careful sometimes with language when I talk about that work. It's not that I'm saying that, right, Ethiopia chose to put a dam at that spot because it knew there were going to be costs downstream in Egypt. But what is true is that if I'm doing imagine I'm actually doing a benefit cost analysis of a dam. And I don't think, a lot of places don't necessarily do a full-blown one of those, but at least you're kind of weighing pros and cons about locations, right, and being as careful as you can. And if I know there are downstream impacts on fisheries or water supply or anything else, I'm going to at least partially discount any of those impacts that occur past my border, right? I might count, I'm going to go right to the border and I'm going to say, okay, this is what's going to happen. And even in the Indian case that I talked about, they still might get that wrong, right? They still might not have net welfare gains from a dam. But at least, right, that, and maybe they thought about their next downstream neighbor, maybe Sudan, right? But did they really, so the question is not so much, am I trying to screw my neighbor, but am I not necessarily sort of doing full accounting of what the impacts are, because some of those impacts happen over a border, okay? So, again, I'm pretty, I'm always careful, right, in these econometric analysis. I don't want to say, okay, it's 27%, right? I'm less focused on the number, but I'm pretty convinced by the fact that we see this sort of stick from model to model to model. We're controlling for lots of different physical characteristics of location and so on, that it tends to seem to be true, right? That we see more dams in these rivers that are upstream of international borders than not. And that, to me, suggests, right, that we have a kind of common property problem. And it's actually not that surprising. It's a pretty classic externalities case where I've got an upstream riparian. The presumptive property rights are to that riparian. They're going to exploit water resources, right? There are going to be some downstream costs, and they're going to try and maybe shift, as much of that they can of that outside their borders, because it doesn't sort of count on their ledger, at least without some sort of adjustment factor, right, for not being as politically valuable to them. Does that make sense?
Yeah,
Okay.
that's useful clarification.
Thank you. Okay, we have a question over here.
Actually, it's a quick contribution to what he just raised. When I saw the geodata, I remembered some work I did in Burkina Faso, down in West Africa. And what happens is, as he said, everybody looks at upstream benefit. So you have a dam put up on the Black Volta. I don't know if you're familiar with it. And every year, whenever the dam overflows, they actually relocate the people.
Yeah.
Annually. So it's
Yeah.
a permanent problem.
Yeah.
World Bank funded it. People are moved every year, or people have to die, farm animals have to die.
Yeah.
And the benefit is for upstream Burkina Faso.
Yeah.
Downstream Ghana has to face this issue every year. So it's more of systems in place, because there are treaties and documents governing the operation and everything. But in reality,
Yeah, there's a
It's-
cost, right? And the
Yes.
question is, right, how much do I count that cost? Well, if it's fully within my borders, I still may not, right? I still may build the dam, but at least there's this incentive, right? And the political pressure and all that stuff varies, right? Whether I'm in China versus India versus Ghana, right, versus the United States. We have different ways in which those costs are going to influence that dam siting process. But to some extent, right, at least domestically, we're all kind of talking about the same thing. Once we cross a border, right, I may negotiate with another country, but I'm still in a position of strength relative to that country, right? Because I currently control the water resource, right, and I'm going to try and use it for the sort of maximum net benefit domestically. So it's a very important question. And as far as knowing individual dams, I mean, it's the embarrassment of being a sort of large N statistical person, is that, okay, there are 5,000 black dots in my data, and I've looked at some of them closely. If they look funny, right, or is there something a little weird or something a little great, right, I get closer. But the rest of them, right, are just those black dots. And so I do really my very best to control for other factors, but I unfortunately don't get to know those individual black dots as well as I should.
thank you.
Sure.
This is a question about actual treaties. It seems that in the case of building a dam on the river, one country has the power to build the dam,
Yeah.
and the other country, what powers do they have to
Yeah.
negotiate a reasonable treaty?
Yeah, I mean, that's why, in some ways, right, to be a little skeptical about treaties, right? So this is why I sort of say, well, you might see them just because, you know, we're Canada and the US and we have this underlying propensity to cooperate, and so you're really just formalizing that in the treaty, and whatever we're doing over this particular river, if it's the Columbia or the St. Lawrence or something like it, we would have done anyway because we have all these other relationships, right? So it's not the treaty per se that's making things better, okay? It's more that good relationship, okay? On the other hand, it could be, right, that, you know, I've got a treaty in place because, you know, eventually, you know, Ethiopia and Egypt and Sudan kind of get together and decide we've had all these problems, we've got to, and either way, if I look and I regress, you know, water, you know, the dam building on treaties, I'm going to get a messed up estimate what the impact of that is because I don't really understand the sort of underlying mechanisms very well and I haven't modeled them carefully. So we do have to be super careful about that. But you're right. I mean, really what it is that, again, if the sort of presumptive property right is where the water is, where the water starts, then the only thing you can say with the treaty is that, right, there are other things, you know, so maybe there are trade relationships or other things, other levers that countries may have, you know, to try and I don't know the particular case between Ghana and Burkina Faso that was asked about earlier, but maybe, right, between those two countries, there's some incentive, right, for the upstream country to act as a good neighbor. But it certainly is, it's a different position than, you know, if you have a border river, right, and you've got countries that both sort of experience benefits and costs from each other's behavior. This kind of pure upstream-downstream relationship, you know, the sort of downstream countries are to some extent at the mercy of upstream. And I think that's in some ways why the Nile case is particularly interesting. I mean, Egypt did that development. I mean, they have the Aswan Dam and others a long time ago. Well, Ethiopia is now at a period of its development where it can afford large dams and hydroelectricity, and that's, you know, sort of great for its people, but it also means that all of a sudden, right, we're in conflict over resources, and Egypt happens to be the downstream country. So it's a difficult problem.
After your talk, I have a feeling. Do you think is currently the economic theories are not good enough to even try to explain this stuff? Do you think so?
Yeah. So, I mean, my feeling is that explaining this stuff takes more than economic theory. I think it can go a little ways, right? This kind of theory of common property, and I can show empirically that this seems to be relevant.
I think probably like the transboundary issues.
Yeah.
I think probably that's a political domain, yeah, not economic issue, yeah.
Well, I think it's definitely both, right? Because we can look at the benefits and costs of that behavior, and we can say, well, gee, right, if I was managing this river optimally, right, given the number of countries that it flows through, I wouldn't have made that choice. And so I know what the net cost of that is, right, for all of the countries in the basin. And so, you know, it may be that where to site it within a country is a political question, but the ultimate impacts are economic questions that can be explored, I think, as well.
Thank you for the presentation. I also enjoyed the talk and also the way you analyzed two prominent forms of adaptation which are considered separately often.
Yeah.
And one of the aspects is this institutional inertia or challenges to adaptation. And I wonder if you could comment on the role of transaction costs and how you account for transaction costs in both models.
That's a great question.
In both the models and the empirical analysis of
that's a great question.
markets and
dams. So the question is about transaction costs, and I'll talk more about the water markets context because that has been studied by others and is also a piece of what we're working on with my colleagues at Penn State in trying to think about that, right? What is it that drives these trades, and is it really the kind of low-cost trades that happen, and the ones that need to happen are the ones with the higher transaction costs? So the transaction cost, the idea there is that in a market, for example, right, if I want to move water from farms to cities, it's not like I can just go down to the grocery store, right, and sort of buy some water. I have to find that potential trading partner. We've both got to hire lawyers. We've got to deal with the fact that we have current rights regime that's got to be changed and negotiated, so we're also going to have to negotiate with the state over that. So there are these kind of costs of those transactions that play an important role, and there certainly are analyses that have been published showing that those are really important in water markets, and to the extent that we see these being kind of thin markets that don't have many trades, or the frequency of trades is not what you would expect given these vast differences in value and in prices, that's at least in part attributable to transaction costs. So there's some work on that. That's sort of a margin on which we're working currently also on the data for the Western U.S. I think it's a really interesting question for the infrastructure case. It's harder for me to think about how to respond to that. On the one hand, you can kind of think about that treaties case as being, right, maybe if the transaction costs weren't so high, maybe we'd have more of those, right? And maybe that would tell a different story than what we've found, that, weekly treaties seem to mitigate this resource sharing problem. Other than that, it's hard to say, to say a whole lot more about that. It may also be that when we look at this kind of stiffness in the adaptability of those institutions, that's in part due to transaction costs. But again, then I have these counterexamples where we've got countries that have tried, right, and really it's not so much a transaction cost story, it's the other party would be harmed by that change, right? So basically think about it, we have a treaty, even if that's, sort of optimized, then the whole hydrological regime is shifted. It's now not optimal, but it's better for some countries than it is for others, and nobody, right, the sort of if everybody has to agree to change it, and the losers are not going to agree, that's more of just a pure incentives question than it is a transaction cost question. So I think in the infrastructure side, it's a little bit of both, probably, sort of incentives plus transaction costs. I think on the water market side, it's probably a lot of transaction costs, and maybe the incentives problem is smaller.
Okay, well, thank you. I just want to thank you again, Sheila, and we have a gift for you, a small gift
so
from the
nice.
Water Institute.
Well, thank you.
And please join me in thanking Sheila.
Thank you.